In the future, a plane capable of shuttling the President of the United States around the globe at hypersonic speeds Mach 5 times faster than the Concorde, could become the new Air Force One. When I first heard this claim from Hermeus in 2021, I was skeptical. Building a passenger plane to travel at such speeds seemed like a far-fetched dream. But then they released a video showcasing a working turbo-ramjet engine, and my curiosity was piqued. I reached out to Hermeus for a behind-the-scenes look at their work, and what I found transformed me from a skeptic into an optimistic supporter. Hermeus, a company any aeronautical engineer would dream of joining, is pushing the boundaries of aviation with a bold vision. The company's origins, as described by CEO AJ Piplica, were humble. It began with just 4 founders working in his basement, accompanied by 2 dogs. Leaving stable, well-paying jobs, they gave themselves 6 months to determine if their idea could take flight. Their goal was to create a plan for high-speed passenger travel within a decade, attracting top talent, capital, and customers. Starting from scratch, they faced the daunting task of turning a concept into reality. Unlike software startups, which can be bootstrapped with minimal resources, hardware startups like Hermeus require significant investment. Raw materials, manufacturing equipment, and factory space are costly, and the competition for skilled engineers is fierce, with companies like SpaceX, NASA, and Apple vying for talent. Hermeus's path to building a hypersonic plane is fraught with challenges. The commercial aviation industry is tightly regulated, and even established giants like Boeing face hurdles in certifying new technologies. Past attempts at high-speed flight, like the Concorde, Mach 2, and military planes such as the SR-71 and XB-70, just over Mach 3, are no longer operational. Developing a Mach 5 passenger plane with no intermediate revenue stream requires patient, deep-pocketed investors. Hermeus's founders recognized this early on, understanding they couldn't simply raise billions to build a commercial jet. Instead, they drew inspiration from SpaceX, focusing on solving critical problems for customers along the way to generate revenue. Their initial focus is the national security sector, a strategic move that secured their first round of funding. The U.S. Air Force, one of Hermeus's key investors, is keenly interested in hypersonic technologies due to growing national security concerns, particularly regarding China's advancements. China's rapid progress in high-quality hypersonic weapons, which can evade detection until it's too late, has alarmed U.S. officials. Unlike intercontinental ballistic missiles, which travel through space at speeds up to 7.8 kilometers per second but follow predictable trajectories, hypersonic missiles cruise within the atmosphere at lower speeds, making them harder to detect due to the Earth's curvature. Hermeus aims to address this by providing testing solutions, not necessarily by building weapons. Testing hypersonic technologies is a significant challenge, as I learned during a visit to a hypersonic wind tunnel at UTSA. Dr. Chris Combs explained that while smaller-scale wind tunnels are cost-effective, large-scale facilities can cost hundreds of thousands to millions per day. For full-scale vehicle testing, flight tests are often the only option, costing around $10 million for a sounding rocket test. Hermeus's first aircraft, Quarterhorse, is designed to provide reusable hypersonic flight testing services, competing with expensive-sounding rockets. It will serve clients like the U.S. Air Force, NASA, and SpaceX, offering more data collection time in the hypersonic regime. This approach not only generates revenue but also builds expertise for Hermeus's ultimate goal, a commercial hypersonic passenger plane. In April 2021, Hermeus secured a $60 million contract from the Air Force, followed by $100 million in Series B funding in March 2022, led by Sam Altman. This funding has fueled the development of their critical component, the engine. Unlike Boom, a supersonic startup that faced setbacks when Rolls-Royce withdrew as its engine supplier, Hermeus opted to develop its own turbo-ramjet engine from the start. Chief Operating Officer Skylar Shuford showed me their first subscale demonstrator, a rugged prototype using an off-the-shelf jet engine wrapped with custom 3D printed components, including a precooler and a shared afterburner ramjet combustor. The precooler allows the jet engine to operate at higher speeds by cooling incoming air, pushing it to Mach 3.3 conditions similar to the SR-71's operating environment. This engine, developed with just $1.5 million and a team of 8 and 9 months, proved the concept. Hermeus then progressed to Chimera, the engine for Quarterhorse, which I witnessed during a test at their facility. The test, conducted with a modified General Electric J85 engine used in the Northrop F5, was powerful enough to make the test building feel like it was lifting off. To make this accessible, let's break down the engine technology. Normal jet engines have speed limits due to their compressor and turbine blades, which overheat as air is compressed at higher speeds. Ramjets eliminate these moving parts, using the plane's forward motion to compress air, but they require high speeds to function. A turbo-ramjet, like the SR-71's, combines a conventional jet engine with an afterburner to reach the necessary speed, then bypasses the compressor and turbine to operate as a ramjet. Hermeus's precooler enhances this by cooling incoming air, allowing the turbojet to push closer to Mach 5 before transitioning. This transition is tricky. If not executed quickly, the plane could decelerate too much, risking failure to engage the ramjet or causing passenger discomfort. Hermeus tested this transition at Purdue University, simulating high-speed conditions with high-temperature air. Quarterhorse Mark 0, a ground vehicle, has helped Hermeus refine in-house manufacturing techniques, leveraging advancements like large-format 3D printing and massive CNC machines. They're also exploring AI-driven robotic panel forming with MOLABs, which could reduce costs for shaping high-temperature alloys like Inconel and titanium, materials that pose significant challenges for the Senior 71's engineers. The SR-71's titanium parts required immense forging pressure, leading to 90% material waste. Hermeus's modern techniques aim to minimize such inefficiencies, enabling faster design iterations. Hermeus targets Mach 5 to stay at the lower end of the hypersonic regime, where ramjets are viable and metallic structures can withstand thermal loads without relying on experimental ceramics. Their vehicles will face unique challenges, such as thermal cycles driving lifespan rather than flight hours. Initial quarter-horse variants will have limited reusability, focusing on gathering data to refine maintenance models. The next vehicle, Dark Horse, will be a fully reusable, uncrewed platform for defense missions, similar to the SR-71. Finally, Halcyon, the passenger plane, will use compression lift like the XB-70's, folding wingtips to enhance range, potentially enabling a New York to Paris flight in 90 minutes. This speed could unlock significant economic benefits, as historical transportation advancements like Roman roads or high-speed rail have driven GDP growth by facilitating trade. Hermeus estimates a $4 trillion GDP boost for economies with access to this technology. However, high fuel costs, increased maintenance due to aerodynamic heating, and limited passenger capacity will make tickets expensive, likely targeting business and first-class travelers initially. AJ Piplica envisions a Tesla-like strategy: start with a premium product and improve efficiency over time. Energy storage and production advancements could eventually lower costs, but economy-class hypersonic travel remains distant. Hermeus's collaborative culture, led by experienced engineers like Tonio Martinez, formerly of X-51 Waverider, SpaceX Crew Dragon, and Divergent, fosters innovation. Engineers and technicians work closely, iterating designs rapidly. This environment, where critical thinking is encouraged across disciplines, contrasts with siloed corporate structures. Tonio emphasized the value of engineers seeing their designs come to life, learning from machinists and technicians to refine parts. This hands-on approach accelerates development and attracts ambitious engineers. Inspired by Hermeus and similar companies, I launched Propeller, an engineering job hub featuring roles at innovative firms like Hermeus, 40 openings, including lead manufacturing engineer and principal thermal engineer, and Relativity Space, 171 roles, like senior aerothermal engineer. Visit startpropeller.com to explore opportunities and sign up for updates on engineering jobs and news. Hermeus's journey from a basement startup to a hypersonic pioneer is remarkable. With a clear revenue path, cutting-edge manufacturing, and a talented team, they're turning skepticism into optimism, one Mach at a time.